Okay, we're today talking about the law of sines. The law of sines helps us to find angles and sides of a triangle if the triangle is not a right triangle. So previously we dealt with the right triangles. But if none of the angles of a triangle are 90 degrees, then we call the triangle oblique. There's some special cases, when you have two sides the same, you've got an isosceles, but all of those would be called an oblique triangle. So one of the first things we need to do is we've got to label our angles. So A, B, and C. Again, we use capital letters to identify our angles. And to identify the sides, we're going to use lowercase letters to represent the length. So the length of this side we would call little a because it's opposite angle A. The length of this long side we would call B because it is opposite angle B. And the remaining side we would call C because it is opposite angle C. And to solve an oblique triangle means to find the lengths of its sides and the measurements of its angles. And to do this, we need to know one of the following things. We've got 4 different cases here. So case 1, you know one side and 2 angles. So this could be called angle, side, angle, or you could have side, angle, angle. Remember those from geometry? Case 2, you have 2 sides and an opposite angle. So 2 sides and the angle that is opposite them, which would be C in this case. This is called side-side angle. And this is a special case, so we're going to come back to that. Both of these, you would have to use the law of sines to solve. Case 3 and 4, case 3, you have 2 sides and the included angle. This would be called side, angle, side. So going from one side, including that angle, and then the next side. So right here, if you had, let's say, side B, angle C, side A, you could use this one. And case 4 is if you have all 3 sides. So this is called side, side, side. In these 2 scenarios, you need to use what's called the law of cosines. And again, there's different laws here, and we're going to go through all of them. But the law of sines is used to solve triangles for which case 1 or case 2 holds. And again, that's where you have one side and 2 angles, or you have 2 sides and the opposite angle. Okay, so the law of sines very simply says where sides A, B, and C are opposite the angles A, B, and C, that the sine of angle A is equal over the length of side A is equal to the sine of angle B divided by length B, which is equal the sine of angle C divided by the length of C. Okay, so if we were trying to solve this, let's see what we have here. We've got angle A, we've got angle B, and we've got one side. So let's go ahead and sketch this. First thing we're going to try and do is let's identify the missing angle. I've got 2 angles. So 40 plus 60 is 100. So angle C must equal 180 minus 100, or 80 degrees. So let's go ahead and designate this. Let's call this A, B, and C. Angle A, we're told, is 40 degrees. Angle B, we're told, is 60 degrees. And this may not look proportional. That's okay. Angle C, we calculated, is 80 degrees. Okay, so we've got those. And when it says solve the triangle, that means we need to find any missing angles and any missing sides. So the first thing we found was the missing angle, which was not 100, it was 80 degrees. So we've got that. Now I need to find these lengths. I do know the length of A is 4. Remember, A is opposite angle A. So I still need to find length of C and the length of B. So if I'm going to use my law of sines, I have to use this angle A because I know both the angle and I know the length. So sine of 40 degrees over 4 equals the sine of angle B, which is 60 degrees, divided by length of B. Okay, so if we have to manipulate this now, because we're trying to solve for B, cross multiply here, so we get B times the sine of 40 degrees equals 4 times the sine of 60 degrees. Divide both sides by the sine of 40 degrees. And we can now solve for B, because those will cancel there. So let's plug this in the calculator. So we've got, let's clear this, 4 times the sine of 60 degrees divided by the sine of 40 degrees. So we get that side B must be 5 point, I'll have to round that up, so 5.39. There we go. I already have room on my paper. Now I also need to find side C. So again, I'm going to go back to sine of 40 degrees divided by 4. So that was sine of angle A divided by side A is going to equal sine of angle C, which is 80 degrees, divided by little c. Again, we're going to cross multiply here. So C times sine of 40 degrees equals 4 times the sine of 80 degrees. Divide both sides by the sine of 40, and we can solve for C. So little c is equal to, again, parentheses 4 times the sine of 80 degrees this time. I've got my parentheses matched up, divided by the sine of 40 degrees. So that side C is equal to 6.13. I'd have to round that up. So I solved my triangle. I was missing one angle, so I found that angle by subtracting the other two from 180. I had one side, and I had to solve for the remaining sides by using the law of sines. So I plugged in what I had, cross-multiplied, and divided. So I found side B was 5.39, side C was 6.13. Okay, and turning this over to example 2, I've got a triangle that I've got two angles, and I've got a side. So according to our paper, we said that if we have two sides, or one side and two angles, we could definitely solve this. So let's go ahead and draw our picture. Again, it doesn't matter what this looks like. So A, B, and C. A we know is 35 degrees. B is 15 degrees. C we don't know, but we know angle, our side C is 5. Okay, so the first thing we want to do is find angle C. So capital C. Well, to find that again, we add these two together, the two we know. 35 plus 15 is 50. Subtract that from 180. So angle C must be 130 degrees. And I like to just write these in as we're going. We don't know side A, we don't know side B. Okay, but we know enough information, we can solve this. So if I take the sine of 130 degrees divided by the length of 5, that's going to be equal to the sine of 35 degrees divided by A. So again, we're going to cross multiply here. So A times the sine of 130 equals 5 times the sine of 35.